soldering iron, it decided to puke out on me. I got this thing about 30 years ago, and I never really used it until about 7 years ago, I guess. And when I first started using it, I just used it the way it worked, and that was it. And that was, you turn it on and it didn't matter what you set the temperature to, this needle just went all the way over, and it was hot all the time. So hot that it, burnt up the tips a lot. So I decided to check into it a little bit, and found a dual op amp in there that was toasted, and it's a I have a new one right here, a new used one right here. It's a LM358N. I replaced that and it started working again. Now, to give you some little back information on this, I used to be a electronics service tech for Sears, and they were throwing a bunch of stuff out, and I decided to keep this. And this was something that probably blew up way back then, and somebody tried to fix it and it blew out again or something, I don't know, but they just left it. I was going to throw it out, so I decided to keep it. So this chip I did replace about, I'm going to guess, 7 years ago, and it worked fine up until just recently. So I'm going to replace that again and take a little bit more time and see if I can figure out why it's blowing. But I have no information on this at all. Model number 12-070. It's really old. There's no schematics that I could find. I can't find any information on it. So I'm just going to do a little snooping around in there and see if I can figure it out. I created my own schematic from looking at the board and tracing out everything, but right now it's in very rough condition. Little bit difficult to read, but I'll fix that up. So if anybody has any information on one of these, I'd appreciate it. It'd help me get this thing working properly again. Now, I'm assuming that they replaced this chip at one time or another, and when I was in there, I also noticed that it looked like there was another component replaced, which was a variable resistor, I believe, potentiometer, or whatever you want to call them, because it doesn't look like the other ones. So let me show you what this thing does. Let me plug it in over here. I'm just going to set this in another. I got another thing over here that we'll put that in so that don't sit down and get warm on anything. So what happens is I'm going to turn this on. We'll start out low with nothing. When I turn this on, it'll start to warm up a little bit. You can see our green light come on. It starts to think it's warming up a little bit, but when it calls for heat, it just shoots right across and our red light doesn't come on. So if you watch this needle, it'll get up, it usually gets up about the 200 mark, and then it just starts freaking out. And it doesn't matter where I have this. Anywhere above the 200 mark, it's going to call for heat. Once it does, I can't do nothing about it. I got to just turn it back off again. Otherwise it'll burn up the tip like it was. So here's about 200 right there. So we should probably see it start freaking out here really quick. There it goes. See, it's starting to jump around. Doesn't matter where I put this, it just starts freaking out. And when it calls for heat, our red LED doesn't come on either. That's not on, so it should be really bright like this one. Yeah, there you can see it. Okay, so now it's calling for heat, and it's making a liar out of me. I mean, you've seen it mess up there a little bit, but usually after that it just shoots right over, and it just stays fully on high. But now it's making a liar out of me, so let me turn off the call for heat. It's right on the border, and you can see it freaking out. Yeah, so there, now it's all the way over, and it doesn't matter where I put that. I have that all the way down now, and it's still way over at max, beyond max, and our red heater light is not on either. So this is what it does. And the only thing I can do is just turn it off. But until this thing cools down completely, you know, it'll start all over and it'll do the same thing again. But even if I turn this up a little bit and I turn this on again, it just shoots. You see it shoot right over to the other side. So that's why I'm going to replace this dual op amp again. But I want to try to figure out why that dual op amp keeps blowing. And it's going to take a little bit of digging probably, because I don't have no information on this thing. So we'll see. Let's pop this thing open. This is warm now, but not too much. I measured the heater and the thermocouple. Let me put this, the heating element, I should say, and the thermocouple, and they're about right. So let's see. This is going to be the thermocouple right here. If I can, yeah, that's in 1 and 2. It's not going to read because it's warm, but it was reading 3 ohms. This is the heating element, and that'll go down. When I measured it when it was cold, it was about 12 ohms. So it'll probably reach 12 ohms if we just let it sit here and cool down. But we'll have to check this thermocouple again when it cools down, because right now it's not reading. So once that cools down, that does read, like I said, 3 ohms. So I don't think there's a problem with that. Alright, pop the cover on this thing, see what's going on the inside. So this is what we got in there. This here is, let me zoom this down a little bit. Might be a little dark, the exposure's kind of low. But this is the one that's bad right here. I replaced that, and it started working again. What seemed like to be normal. Now this pot right here was the one that I think has been changed, because it's not like all the other ones, these other 4, and so that's why I think that's been changed. And that's a 103, I believe it is. I'll slide this over here, and then I'll put a close-up right here for you. But that's all we got in there. So it was easy to make a schematic for it, but since I don't do schematics all the time, or I don't really have a reason to do them, it's kind of amateurish at the moment, I guess. So I need to work on that. Now, I don't know what gets hot in here. Maybe this gets hot when this is on and plugged in. We can try it and see when that thing starts freaking out. Let's see, we'll plug this back in. We'll turn it on. Turn it up so it calls for some heat. Once it gets to a certain point, I don't, like I said, I'm not familiar with this, so I don't know if right away that should come on, or if it does wait until it gets up to a certain degree before it kicks in. But we'll have to wait until it gets to about 2 again, I'm guessing. 200 degrees Fahrenheit or 100 degrees Celsius. And then I'll put my finger on that dual op amp and see what's going on. See if it's getting hot. I'm sure it probably is now because it's blown, but starting to mess up now. So it's not even hot at all. Good way to get zapped if you ain't paying attention to what you're doing, right? Nothing seems like it's getting hot. I'm not going to touch that, of course. That's the trach, which what is that? That's a BT 136, it looks like, or a 130. Yeah, maybe 30. Yeah, BT 136, it looks like. So I got to figure out what's causing it to do that. After, like I said, it's been about maybe 6-7 years since I fixed it, and now it's doing it again. So that's our project for today. The iron cooled down, so I wanted to show you this real quick before we take that board out of there. It's been, I don't know, maybe 10-15 minutes or something like that. This is the thermocouple. So that's even lower than what it was before. It was, like I said, it was 3. There's 3.1. 2.5, but it's maybe that thermocouple is flaky, going bad or something. Because I thought too, when I was moving the cable around, I thought that was changing, and I looked at that for quite a bit and tried to figure it out, but then it convinced me that my probes were the ones that were making it change, because I think my probes on my meter are about ready to need to be replaced. So that's the thermocouple right there, and then the heating element is 11 point something, so almost 12 ohms. So besides, you know, maybe having a short in here or something somewhere, I don't think there's anything wrong with the thermocouple or the heating element. But like I said, I went through here and I wiggled this and I kept my eye on that, and I couldn't really see any big change or anything like that. So I'm going to consider this as being good for now. And so we'll set that aside and carry on. Now, my soldering iron that I used for most of my life is this one right here. I think it's just an old Radio Shack one. I don't know, 25, 30 watt or something like that. But I got that one heating up, ready to pop that chip out of there. So let's take this apart while that's heating up. So last time I had this apart, when I moved this around, some of these wires broke off, so I had to resolder those in there. So let's hope it doesn't happen this time. But if it does, you know, just have to put them back in there, I guess. So let's throw the other one in. Make sure we put it in. Number 1. Even has a number 1 right there. I don't know what that chip there was. That spot wasn't filled with anything, so neither was that resistor spot there. I think it's an R, but wasn't nothing in there either. That looks pretty good to me. Let me clean that up just a little bit. Alright, got that all cleaned up. That looks a lot better now. Get all that flux off that back of that board. Somebody must have went through and touched up everything on there. I don't believe I did. I usually clean up my stuff like that, but so I guess we'll give it a try, and without touching anything else, and see if it acts like it wants to work right, or still freaks out, or oh, I was gonna say something. Yeah, I don't know if any of these variable resistors are set properly, because of the fact that, you know, I think this one's been replaced and somebody else has been in here. I don't know if any of these have been turned, and maybe that's why that component keeps blowing, because things aren't set right. I wouldn't know what to set them to anyway, because I don't have a schematic. But so let's just see if let's just see what this does for now, and we'll go from there. So I got this turned all the way down. Let me get it plugged in. I thought I plugged it in. Alright, plugged in. Let's turn it on. Let's set this up at I don't know, maybe about 300, I guess, in between there. 300 Fahrenheit. We'll wait till it comes up to our 2, I guess, like it usually does. See if we get a call for heat like it's supposed to, or you can hear it humming. Transformer in there. So it's going past 2. About 3. And I forgot to get a wet sponge or something here. Oh, there it goes. It's starting to act up a little bit there. Oh, the call for heat kicked on. Now it turned off. Oh, it's still freaking out. Oh, maybe we blew that new one that we put in there. New used, I should say. Let's see what this does here. Oh, shoots right over. So I guess putting that chip in there didn't help us out. Either that chip was bad or there's something in here that's making it blow real quick. Have to take a deeper look. Whew. He said as he wiped the back of his hand across his forehead. This thing had me chasing I don't know what, all over the place. But we got it figured out, and it's not good news for this this soldering iron. So I'll tell you what I started with. Remember we replaced this, and I had a few of these, and I tried them in here and with the same result. So that led me to believe that there wasn't nothing wrong with this one. I went through and I replaced these caps, these transistors right here. I replaced that diode, these capacitors. I changed this variable resistor because the other one broke. When I was turning it, it just snapped right off, so I replaced that. This one is a says 24 on it, so 20,000 instead of the 103 that was on there. 10,000. I found some old notes that I had and realized that I replaced this trach at one time. So I put an original one back in there. I had all kinds of them, and the original one is a MAC 228A6. That's the original one that was in there. So I have that one back in there now. And with all that, I mean, I replaced all these components, but then after I replaced them, I still had the same problem. So I went ahead and I put all the original stuff back in there. Even this one is the original one that we first took out earlier in the video. I put that one back in there because I put one that was a known good one in there, for sure was known good, and it still reacted the same as it has been. So I put all those in there and tried them, and the only one that was different was the Motorola one. It's the same LM358N, but the Motorola read different. If you put a ohm meter on the leads and go around it, you know how you would check a chip, then this one's the only one that read completely different than all the other 4. But these 4 read all the same. Why that is, I don't know. I mean, there's a little bit of difference in the manufacturing, I know that, but so let's see. That's where we ended up there. So what we got going on here, let me start this video over here. As I got this turned on, see, get it up here so you can see it. And I'm just going to turn this up. We'll just turn it up to 500 or everything that I did. No matter what I did, it just acted the same until I come down to the thermocouple. So this whole venture ended up being, I don't know if I said it in the beginning, but I suspect the thermocouple, and the thermocouple is the main problem why this needle would just shoot right over. So right now I have a different thermocouple connected. You can see right here there's a spade connector on the end of this thermocouple, and wires come around and they connect. I have it soldered into where the original thermocouple was connected. So this black wire and this white wire is the old thermocouple. I have it disconnected, got the new thermocouple plugged in there, and now we don't have the problem at all. Now the only problem we have with this, and you can see that the heat's going up, it's going to 450 almost. The only problem with this now is for some reason it's not allowing me to have a lot of control over this. So it's pretty much anything over 500 or something like that is nothing. It's the same. The highest I can get this to go is 550 degrees Fahrenheit. And that's it. I can lower it and it'll go to some lower ones, but so I don't know if that's a thermocouple issue. It could be, because the thermocouple that I acquired or procured, or however you want to put it, is used, and it's many years old, but it still works 100% better than the one that's inside here. And you can see that because it isn't freaking out. So I mean, this is all a test anyway, so the whole thing here is this is probably gonna head for the garbage, because like I said, being over 30 something years old, if anybody knows exactly how old this is, hey, let me know. I'm curious to find out how old it is. But as old as this is, 30 plus years, I'm not going to spend the money on fixing it. For one, I can't find a new iron, and I don't want to spend the money on buying a new iron and then making it work on this one. Why not? Because I can just buy a whole new soldering iron that works just like this one for 110 bucks, a Weller, you know. So there's no sense of going through all that. So this one's seen its days. It's time for the scrap heap. Probably could use it for parts or whatever, but it's not worth fixing. So you can see that's the thermocouple is the issue. And this meter that I'm going to have right here, right there, I'm going to do just a little video on that. That's a it was a calibrated piece of equipment way back in the day, and it still works. And I was just going to cover that a little bit because it's kind of interesting. I have 3 thermocouples that we'll play around with on there, and troubleshoot some thermocouple issues, a couple thermocouple issues I've noticed with doing this whole project, but we'll cover that later. So I'm going to turn this off. Now I have this my meter was connected to the thermocouple that's in here, and it was freaking out, and I can show you that. I'll put that somewhere around here so you can see it. And that's with it connected, and and you can see that the number just continuously goes all the way up and then all the way down, both in the positive and negative, and it just keeps repeating itself like that. So the more I played with this thing, the worse off the thermocouple got, and then it finally just failed. So I'm gonna show you that, but I need to wait for this to cool down. So when this cools down, I'll be right back. Alright, so that's cooled down pretty good. So I know before I showed you the resistance of the thermocouple that's in this part right here, the original, and it read about 3. Let's see. Need to get my act together here. Now this is the original one that's in there now, and this is what it reads. If I can get this clipped on there. That's what it reads when it's bad. So it was reading 3 ohms through all my messing around and everything. It went completely bad. And the video that or the little image of this I told you that kept going all the way up and all the way down, that was a measurement from this thermocouple, I believe, when I still had it connected in here. And I was holding the probe on the connections here. The green one you can see, and then the black one's way in the back. I'll get my fingers out of the way, but this green one right here is the negative of the thermocouple, and the black one is hidden way back behind there. And I believe that's where I was touching it when that number was going all the way up and all the way down. But you can see our ohms reading is definitely bad now. Let's see what it reads on this good one. I don't know if I can do that with it all connected. Yeah, with it all connected, it's about 2.6. See if there's a difference like there was with the original when I swapped the leads. Yeah, so that way it's 4.2. So there's a little bit of difference depending on how you connect it. So this is something else. We'll see what this one does when we disconnect one of the leads from the thermocouple. So now this one is not in circuit, so we have like an open thermocouple. And I believe this is how I tested the original one. It was a few days ago, because I've been on this for a few days, because it's been throwing me for a loop here and there and tricking me. And so we'll put that on DC and we'll flip this on, and the needle shoots right over. That needle shoots right over, just like it was before. And I have this all the way down. Even when I turn it up, it doesn't do anything. So now I was putting, I took it off the black wire in here. And I'm going to put this on the black wire. And I believe that's what we were seeing before, with it just climbing up and down and, you know, forever. Now I'm gonna stick this and get just a light connection the way it was. Oh, maybe that wasn't the way I did it. Held this on here, and it's freaking out. It's not steady. But when I stick this back into where it goes, fail to make a connection. So now it's connected. I don't know why it wasn't getting a connection, and it's steady because it's the thermocouple's in the circuit. So if I pull that back out of the hole where it was soldered in, now we start getting it going all over the place again. So there's another clue if you might have a bad thermocouple. And this thermocouple, if I didn't mention, I don't think I did. This is the new one that I have on here with the spade connector on the end here. I believe this is a K. I looked it up because it has yellow and red coverings on the wires. Both wires are silver, so that tells me that it's a K, and the wires are the chromium and aluminum or wires, the type of wires. So it almost resembles what's in here. So I don't think there's anything else. That's the problem with it. I'm not going to fix it. I'm not going to spend the money. This one was a pain in the butt. Took way longer than what I wanted it to, but at least we narrowed it down to a faulty thermocouple. And the thermocouple in there, you know, they're cemented in there. You can see that white stuff right there where the wires go in. That's all cemented in there, so there's no fixing it or anything. So I believe that's all I wanted to say about this. And we tried. Sometimes we fail. Alright, I guess we'll see you on the next one.